not quite so complex. This one, it's an equilateral triangle, and we know that each side length is 4 inches. But the fact that it's an makes it a little bit easier to deal with. So I got a triangle that looks about equilateral there. And if it's equilateral, that means I can also kind of split it in half into two special right triangles. Now when I split it in half like this, that means this angle here is 60, then I got 30 in the top, 30 in this half of the top, and another 60 down here, and of course this is a right angle. I can do this with equilateral triangles, and it makes it a lot easier to make the calculations. I know that this side is 4, this side is 4, and this whole side is 4, but that means each half is 2. Then the key would be trying to figure out this height of this triangle. Well, that would be 2 root 3 because that follows our pattern of x, 2x, and x root 3 for a special right triangle. If you remember back, 30, 60, 90 triangles are x, 2x, and x root 3. Or it doesn't really have to be x. It could be whatever letter you want. So I know that I have a height of 2 root 3. So if I'm trying to find the area of this triangle, that equals 1/2 times the base times the height. Now I don't have to do a whole bunch of triangles because I'm just doing the one. So 1/2 base times the height. Well, let's figure out what my base is. That's this whole base here. That's 4. And the height is 2 root 3. If I want to simplify this at all, I see that this 1/2 and this 2 will reduce down to 1. So then I have 4 root 3. So my area equals 4 times the square root of 3. My units are inches, so because I'm in area, it's inches squared. Wow, that was a lot easier. Let's try another one. Very similar. There I have a regular octagon. Sides are 8 centimeters each. Let's make an octagon here. That means I need an 8-sided figure. That would be like this shape here. Okay, now just to make this a little bit more round, let's make sure that that's nice and round. Is that nice and balanced? It's pretty close. Maybe we need to pull this in a little bit here. We can look at it like a stop sign, and in fact I want it to be kind of like a stop sign just for the angles that I'm going to be looking at here. Now I'm going to split this up kind of differently than most people would, I would think, but I think it's going to help me. I know that this is 8. I know that this is 8, and so is this, and so is this, and so is this, and this, and this, and this. What I want to do, though, is try to split this up into shapes that I could find a little bit more easily. So I'm going to draw some vertical lines here. Then I see that I have 2 trapezoids and a rectangle, but just to make it even easier, let's just go for rectangles and triangles. Now something that's really cool is I already know a few of these measures. For example, here on the inside I know that this is 8 and 8, and this is 8 and this is 8. So this square in the middle is 64. Now if I know that that's 64, what I do need to figure out is these rectangles here. I'm going to color them blue, and they're actually all congruent because this is a regular polygon and it's got a lot of symmetry to it. And then I need to find these triangles here. I'll color those red just to color code some of the work that we're going to be going through. So let's start by looking at the rectangles. We'll start with blue rectangles. There's one of them. Actually, let's not start with the rectangles. Let's do the triangles first. Triangle's probably going to help us figure out the other pieces. We need our triangle to be red. Let's make it red. This part. This will be red, and we'll fill the inside with this. Whoops, did I jump to a different one? Yes, I did. Here we go. Back on track. So I have a red triangle, but I'm going to change it slightly so that it looks more like these triangles. Needs to look kind of like it's in that corner there. So I know that this triangle has a hypotenuse of 8. And I also notice that it's kind of cut here at a 45-degree angle. So I can actually use that to my advantage to figure out these two legs here. If I know that this is 8, well, that's the leg that would be x times square root of 2, because these two would be my x legs, and x root 2 to figure that piece out. Well, another way of thinking about that, if these two are the same, I could just say x squared plus x squared equals 8 squared. It's just Pythagorean theorem. 2x squared equals 8 squared. 2x squared equals 64. If I reduce this, I get x squared equals 32. Square root each piece. And then x equals the square root of 32, which is really square root of 16 times the square root of 2, or just 4 square root 2. So this piece equals 4 root 2, and this piece equals 4 root 2. So if I were to find the area of one of these triangles, the area of one triangle equals half base times height. I'm starting to run out of a little space here. Let's try and clean some of this out. That's 8. So this area equals 1/2. The base is 4 root 2. And the height is also 4 root 2. So 4 root 2 times 4 root 2 is going to be 16 for the 4's and 2 for the root 2's. And I still have that half there. The 2 and the 1/2 can reduce, so it's just 16. The area of each of these little squares is 16. And I got how many of them? 4. Then the area of 4 of them is equal to 4 times 16, or 64. So the triangles equal 64. The square in the middle also equals 64. That's kind of interesting. So now I need to figure out is the rectangles here. So let's draw one of those and see what we can get with it. Looks like it's about that. So when I'm looking at this rectangle, I know that this side was 8, and then the short side we just figured out was 4 times the square root of 2, because this short side is the same as one of the legs of the triangle. Well, if I wanted to figure out this area, I just multiply those two together because it's base times height. That's going to give me 32 times the square root of 2. That's the area of one rectangle. If I want the area of 4 of them, because I have 1, 2, 3, 4, that's going to be 4 times 32 times the square root of 2. Well, 4 times 32 is going to be 120 plus 8, 128 square root of 2. Centimeters squared, of course. Just like the other ones as well. Centimeters squared, all the way around, all my areas. So to find my total area with everything added together, what's the total? It's all 3. It's going to be the triangles, which is 64, plus the square in the middle, which is also 64, plus this last piece here, which is the rectangles around the outside. That's 128 times the square root of 2. So if I were to simplify that just a little bit, 64 and 64 makes 128. And this over here is going to make 128 square root 2. 128 times the square root of 2. Well, there we go. That's my area. Centimeters squared. Not too bad. I'm splitting it up in a lot of pieces, but not too bad. The area of a square. Oh my gosh, this is so easy, you guys. Just think about it. We just looked at this where we said that this is going to be a 45-45 triangle where those two sides are the same. Similarly, for a square, these two sides are the same as well. So if I'm trying to look at this square and figure out what the area of a square is, it's just area equals x squared. Well, let's figure out what x is. Well, I know that x squared plus x squared equals 12 squared. Why do I know that? Because this guy named Pythagoras, who made a theorem, x squared plus x squared equals the hypotenuse squared. A squared plus b squared equals c squared. That tells me that 2x squared equals 12 squared. 2x squared equals 144. So I'm going to divide both sides by 2. I get x squared equals 72. But 72 is really 36 times 2. So my x, if I square root both sides, is the square root of 36 times the square root of 2, which is really 6 root 2. So this equals 6 root 2, and this equals 6 root 2. What I need to figure out then is the area of the whole square. Well, it's x squared, which means it's 6 root 2 times 6 root 2. If I multiply the 6's together, I get 36. Square root of 2 times square root of 2 is just 2. That brings me back to 72. Now, if I notice that the units are meters, then my area should be meters squared. There's my area. And now we're done. Thank you. Have a good day.